Hello everyone, this is Saurav Kumar from Engineering Physics Department, IT Rookie. Associate Professor Mangosamy who teaches Applied Instrumentation subject in which he teaches us how actually our daily life instrument work. Under him, we need to choose a topic or instrument and we have to describe its function or on the basis of transducer sensor and actuator. And my topic is digital sphygmomanometer. Here is some picture of digital sphygmomanometer. What is blood pressure? I will explain you by giving you an example of a flowing water from tube. Whenever there is a flow of water in tube, if we stop that flow by any manner, the tube face some pressure due to flow of continuous flow of water, and that may burst after some time. That the same thing happened in human body whenever there is a obstacles in blood vessels or heart. The we all knows that the heart is continuously pumping blood to our body, and because of obstacle the blood vessels and heart itself feel some pressure, and that pressure lead to the pain of body, heart attack, and at the worst case, death. Let us understand the functioning of sphygmomanometer. I am using conventional sphygmomanometer. You can say old sphygmomanometer to explain you what is happening in that process. In step 1, when no pressure applied by curve on veins, the red line is lower than diastolic pressure. When there is a relaxation in vein, it feels lowest pressure, which is called diastolic pressure. Here you can see the red line. Red line is here, and this is systolic pressure, and this is diastolic pressure. I will explain systolic pressure in the next slide, but keep looking the red line. Step 2. Pumping started. When we apply pressure on veins by curve, the red line gets upper than systolic pressure and there is a contraction in veins. Also, when there is a contraction in veins, it feels high pressure, which called systolic pressure. I just wanted to grab your attention over there. There is a wings of human hands. It is contracted. In the previous slide, there is a no contraction. This contraction is because of the pressure applied by cuff. And here is the red line. Here is systolic pressure, diastolic pressure. Let's come in third step. Third step and fourth step is very important. Pressure release slowly. When we release pressure slowly, then the red lines comes between systolic and diastolic pressure, which cause a periodic vibration, and we can hear that sound using stethoscope. And at the meantime, when we heard that sound, if it is greater than 120 per minute, it is called high blood pressure. Please pay attention on that red line. There is some wave formed over the red line, and that is the cause of that vibration. When the vibrations start, at that point we called that is the high blood pressure. Step 4. When we release more pressure. Now you can see that red lines come very close to this diastolic pressure, and also the tap tap sound is very low and vanish after releasing some more pressure. Again, we need to count the number of sound before vanishing, and if it is lower than 80 per minute, then it is case of low blood pressure. Here is the red line. Digital sphygmomanometer. In the previous 4 slides, I explained the process of measuring blood pressure using conventional sphygmomanometer. Now, I will demonstrate how we can enhance this process using integrating transducer sensor to replace a certain component of conventional sphygmomanometer. But bulb is basically used to pump up pressure into curve, and we can use motor pump in place of it. This pump or compressor can be considered as a transducer as it converts electrical energy into pneumatic energy. Pressure control valve. Pressure control valve is very important when we are going to third step, and solenoid is the best replacement of it. It is used to release pressure in cuff, the same thing that pressure control valve do. A solenoid valve transducer serves as an electromechanical interface between electronic control system and pneumatic system of device. Uh, I also shared some pictures of solenoid, how it's work. You can go by that picture. I had also numbering that pictures. Now, stethoscope is replaced by double diaphragm. I think this component is very important because at the end it converts that tap tap sound or vibration into a electrical signal that further goes into microprocessor, or we can say circuit, electrical circuit, and that converted into our that displayed into our display. And to understand it properly, we need to go through its working. When the curve is inflected gradually, when the curve is inflected and gradually deflected, the pressure change in artery causes outer diaphragm to vibrate or move. The movement of outer diaphragm causes the change in the air gap between two diaphragms, modeling, modulating the volume of air gap. Diaphragm act as a parallel plate capacitor, and the air gap act as a dielectric between these plates. As the volume of air gap change due to the outer diaphragm movement, the capacitance between diaphragm also changed. The transducer is connected to an oscillator circuit which generate an electrical signal with a frequency that varies according to the changing in capacitance between the diaphragm. Let's come to the almost second last slide's advantage of sphygmomanometer. It's portable, handy, carry, easy to carry, low cost, less maintenance, much accurate and fast. And at the end, thank you very much.